Welcome back. Now we're going to look further at composition functions as well as their domain. In this problem, we are given the function f of x equals x cubed minus 5, as well as the function g of x equals x squared minus x. We're asked to determine or find g of f of x, as well as its domain. So we have two functions. I'm going to color code them. F will be red and G will be blue. Notice we're asked to determine G of F. So F comes second. F is going to get plugged in to G wherever there's an X. That means x cubed minus 5 is going to get plugged into both of these x values in g of x. That's what this notation means. And we can rewrite that. We can say, well, g of f of x means g of f of x. So that means wherever there's an x, I have x squared minus x. And what am I plugging in for x? I'm plugging in the function f of x. So I'm kind of writing this in an exaggerated manner to help you see what we're doing here. Now, in this problem, I probably wouldn't write actually f of x. I would go ahead and write my function that I'm plugging in, x cubed minus 5. And then we have x cubed minus 5. So if you get to this step on your paper when you're working this out, I know that you understand what the composition notation means. The rest of this problem, this is all about being able to simplify correctly. So here we have x cubed minus 5, and that is quantity squared. And what that means is x cubed minus 5 times x cubed minus 5. Also, we have this minus in front of both of these second terms. That's going to mean we need to distribute. So I have negative x cubed, and this last term becomes plus 5. Let me focus now on foiling these two terms. So first, I have x cubed times x cubed is x to the 6th. We add powers when we are multiplying like bases. I get minus 5x cubed minus 5x cubed for my inner and outer terms, which is actually going to give me negative 10x cubed. And then my last terms, negative 5 times negative 5 gives me plus 25. So I still have my minus x cubed and my plus 5. Now we can combine like terms, and my final answer here is x to the 6th. Negative 10 minus 1 is negative 11x cubed, and 25 plus 5 gives me plus 30. So this is the final answer for my new composition function. Now, looking at this problem, we were also asked to determine the domain. If you recall from the previous video, we have to intersect the domain of the interior as well as the domain of the result. So let's look at what that means in this problem. Which function was the interior function? Here, f went inside of g. So f is the interior function. We need to look at the domain of f, intersect that with the domain of our result down here. So if I say, well, what is the domain of the interior? That's the same as the domain of f. And because f is a polynomial, it's x cubed minus 5. There is no denominator. There's no even root. We say that the domain is that x is in the set of all real numbers. Now, if we look at the domain of the result, that means we're looking at this up here, and that's also a polynomial. This is a 6th degree polynomial, and that domain is also all real numbers. So if we look at the overlap where these two intersect, our final answer for this problem, the domain of g of f, will also be that x is in the set from negative infinity to positive infinity, all real numbers. And so that will be our domain for this problem. Now, I know that seems a little silly that I had to go through all of those steps because we could see that it was all real numbers. However, there could be situations where whatever I was plugging in, maybe there was a square root, and when you square a square root, that could go away. So there was a square root that potentially evaporated or disappeared. So we always have to go back, and we can't just look at this end domain. We have to also consider the domain of the function that went inside the other function. Let's just do one more quick example, and the domain on this example will be all real numbers as well because it'll be similar. So we're not going to worry about domain with this problem. Here we're given a linear function, this represents a line, f of x equals 3x plus 2x. And we are asked to find f of x. So that seems a little silly, but essentially we have this entire f function, and we're asked to take that function, 3x plus 2, and plug it back into itself. So here, f of x means f composed of itself, f of x. So my function is 3x plus 2. Notice how I'm writing those parentheses, and what am I plugging into that function, 3x plus 2? I'm plugging in f of x. And f of x, of course, which is given, is 3x plus 2. So I have 3 times 3x plus 2 plus 2. Here we can simplify that. That's going to give us 9x plus 6 plus 2, or rather 9x plus 8. Now, I like to show this example because I think it's interesting to plug a function's expression into itself. But it's really not that hard. And once you understand how a composition works, I feel like this should be pretty easy for you. Now, of course, we're not going to talk about domain because, well, we can. But the domain here is all real numbers, and the domain of the function that was going in was all real numbers. So the domain here, if we intersect all real numbers with all real numbers, where does all real numbers touch all real numbers? The answer would be all real numbers, which would say x is in the set from negative infinity to positive infinity. All right, so that's it for this video. We will do some more complex compositions in the following videos, and we will really have to think about the domain a little bit more on these future examples.